Okay, my dear students, welcome to my lecture. I am Ali Akbar, lecturer in mathematics, Rajugutar Model College. Today we are going to discuss chapter 10, circle, theorem 2. Given statement, equal chords of a circle are equidistant from the center. Equal chords of a circle are equidistant from the center. This is the given statement. At first time, we have to draw the circle. This is the center of the circle O. This is the chord AB. AB is the chord. Given condition, two chords are equal. Given condition, two chords are equal. This is the another chord CD. AB and CD are two equal chords. AB and CD are two equal chords. We have to prove that the two chords are equidistant from the center. This is the given information. This is the given information, that is general enunciation. Now let us now give the particular enunciation. What is the particular enunciation? Let O be the center. O be the center. And AB, CD are two equal chords. This is given. Two equal chords. Let O be the center of the circle. AB and CD are two equal chords. AB and CD are two equal chords. We have to prove that AB and CD are equidistant from the center O. We have to prove that. The chords AB and CD are equidistant from the center O. We have to prove that AB and CD are equidistant from O. Equidistance from O. This is our target. O be the center of the circle. AB and CD are two equal chords, which is given. We have to prove that AB and CD are equidistant, that means equal distance from the center O, that is from O. Construction. What is the construction? OA and OCB join. OA, OCB joined. This is OE, OA, join OA and also join OC. This is perpendicular, this is another perpendicular. OE perpendicular to AB, OE perpendicular to AB, OF perpendicular to CD, OF perpendicular to CD. O is perpendicular to AB, OF is perpendicular to CD. OA and OB joined. OA and OC B joined. B joined. O is perpendicular to AB, OF is perpendicular to CD. OA and OCB joined. That is, let us now draw the perpendicular OE on AB and OF on CD. This is the construction. And also, we have to join OA and OC. OA and OC. This is the required construction. Let us now give the proof. Since O is perpendicular to AB, since O is perpendicular to AB, and also OF is perpendicular to CD, From the above figure it is seen that O is perpendicular to AB, also OF is perpendicular to CD. Therefore, easily we can say that A, from the help of previous class, that is activity, A equal to B, A equal to BE, and CF equal to, and A equal to B, and CF equal to DF, CF equal to DF, The perpendicular drawn from the center to the chord bisect the chord. The perpendicular drawn from the center bisect the chord, because perpendicular drawn from the center, the perpendicular drawn from the center to the chord bisect the chord, This is the given information statement. Activity 1, we have already proved this from the previous classes. A equal to B, this is A, this is B, CF equal to DF, because the perpendicular drawn from the center to the chord, bisect the chord. In this case, easily we can say that A equal to B, CF equal to DF, that is equally divided, AB is equally divided at the point E. That means A equal to B and CF equal to DF, Therefore, A equal to half of AB, because A equal to B, that's why easily you can say that A equal to half of AB, that is 50% of AB, and semi-process CF equal to half of CD, CF equal to half of CD. CD is equally divided at the point F. CD is equally divided at the point F. CD is equally divided at the point F. That's why we can say that CF equal to half of CD. But we have another condition. What is the given condition? AB and CD are two equal chords. AB and CD are equal chords. This is given condition. AB and CD are equal chords, which is 100% given. Equal chords of a circle are equidistant from the center. This is the given information. That's why easily we can say that AB equal to CD. Very, very important theorem. AB equal to CD, which is given. Breaking news, given. Which is also given condition. AB equal to CD. Now dividing on both sides by 2. Half of AB equal to half of CD. Dividing on both sides by 2, or multiplying on both sides by 2. Anyone you can choose. Multiplying on both sides by half. Or dividing on both sides by 2. Multiplying on both sides by half, or dividing on both sides by 2. Because A equal to half of AB. A equal to half of AB. Also CF equal to half of CD. CF equal to half of CD. Therefore, half of AB instead of half of AB can be written as A. Therefore, half of AB equal to A. Half of CD. It is found that CF equal to half of CD. CF equal to half of CD. So this is CF. This is the new condition. A equal to CF. A equal to CF. This is perpendicular to AB. Also F is perpendicular to CD. Therefore, from the above figure, it is seen that this is a right angle triangle. This is a right angle triangle. This is a right angle triangle. In right angle triangle. In triangle now. In triangle number 3. In triangle AOE. In right angle triangle. In right angle triangle. In right angle triangle AOE. AOE. In right angle triangle AOE and also COF and COF. In right angle triangle AOE and COF. In right angle triangle AOE and COF, it is seen that hypotenuse O equal to hypotenuse OC. Hypotenuse O equal to hypotenuse OC. Hypotenuse O equal to hypotenuse OC. Hypotenuse OA equal to hypotenuse OC. Radius of the same circle. 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 Hypotenuse OA equal to hypotenuse OC. Also, A equal to CF, we have already proved from step 2. From 2, it is seen that A equal to CF. A equal to CF. A equal to CF from 2. From 2. A equal to CF. A equal to CF. In right angle triangle, we know to prove the congruent triangle, hypotenuse on one side will be needed. This is the sufficient condition to prove the congruent triangle. In right angle triangle, hypotenuse and one side are equal. In this case, it will be congruent from the properties of the congruent rule. In right angle triangle, hypotenuse and one side are equal, then we can say that this is congruent triangle. In this case, it is seen that hypotenuse Y equal to hypotenuse OC. Also, we have A equal to CF, A equal to CF. That's so easily we can say that the two triangles, that is AOE and COF, AOE and COF, AOE and COF are congruent. Therefore, triangle AOE is congruent to the triangle COF is congruent to the triangle COF by RSS theorem. RSS theorem. By RSS theorem. By RSS theorem. Since hypotenuse on one side equal, so easily you can say that triangle AOE is congruent to the triangle COF by RSS. RSS, that means in right angle triangle, hypotenuse and one side are equal. In right angle triangle, hypotenuse and one side are equal. So easily you can say that the two triangles are congruent. Two triangles are congruent. Therefore, since the two triangles are congruent, so it is crystal clear that therefore OE equal to OF. OE equal to OF. Therefore, easily you can say that since the two triangles are congruent, therefore OE equal to OF. OE equal to OF. But from the above figure, it is seen that condition 4, it is seen that what is OE and OF? What is OE and OF? From above figure, OE and OF are the distances from the center O to the chords AB and CD respectively. But it is seen that OE and OF are the distances from the center O to the chords AB and CD respectively. But OE, OF are the distances from O to the chords AB and CD respectively, AB and CD respectively, AB and CD respectively. From the above figure, it is seen that OE and OF are the distances, but it is seen that OE and OF are the distances from the center O to the chords AB and CD respectively. AB and CD distances, that means this is the length of OA and length of OF, that means distance OE and OF. Another name, this is the length of OE and OF from the center O to the chords AB and CD respectively. But OE and OF are the distances from the center O to the chords AB and CD respectively. This is the distance. Therefore, easily you can say that the chords AB and CD are equidistant from the center O to the chords AB. Therefore, number 5, hence the chords AB and CD, chords AB and CD are equidistant from O, equidistance from O of the circle, hence proved. Again a review. Given condition, two chords are equidistant from the center O. This is our given target, particular enunciation. Again a review. Let O be the center of the circle. AB and CD are two equal chords. AB and CD are two equal chords, which is given. We have to prove that AB and CD are equidistant from the center O. This is our target. Construction. Let us now draw the perpendicular OE to the chords AB and OF to the chords CD. And finally join OA and OC. This is the required construction. OE is perpendicular to AB. OE is perpendicular to AB. OE is perpendicular to AB since OE is perpendicular to AB, OF is perpendicular to CD. Therefore, easily you can say that A equal to B, A equal to B. Also, OF is perpendicular to CD. Therefore, CF equal to DF, CF equal to DF, because the perpendicular drawn from the center to the chord bisect the chord, that is equally divided. Bisect, that means equally divided. That means AB is divided at the point T equally. So we can write down A equal to half of AB, A equal to half of AB, CF equal to half of CD, CF equal to half of CD. Number 2, also we have AB equal to CD, AB equal to CD on condition, which is given. AB equal to CD, which is also given. Multiplying on both sides by half or dividing on both sides by 2. Therefore, half of AB equal to half of CD. But we have half of AB equal to AE, this is AE. Half of CD equal to CF, this is CF. Also, from above figure it is seen that AOE and COF is a right angle triangle, Therefore, in right angle triangle, hypotenuse O equal to hypotenuse OC, hypotenuse O equal to hypotenuse OC, radius of the same circle, Also, A equal to CF, this is A equal to CF. From 2, triangle AOE is congruent to the triangle COF. Triangle AOE is congruent to the triangle COF, because in right angle triangle, to prove the congruent, hypotenuse and one side must be equal. This is the sufficient condition. To prove the congruent. That's why easily we can say that the two triangles are congruent by RSS theorem. What is RSS? RSS, that means in right angle triangle, hypotenuse and one side. Therefore, two triangles are congruent, O equal to OF, because the two triangles are congruent. But from the figure, it is seen that OE and OF are the distances. OE and OF are the distances from the center O to the chords AB and CD respectively. That's why easily we can say that the chords AB and CD are equidistant from the center O to the chords AB and CD respectively. My dear student, thanks everybody. Stay home, stay safe, everybody.
Left approach.